All right, we're going to start learning about more ways to sketch graphs based on what we've learned. Okay, let me get a little better zoom here. Okay, all right, here's this term RATTEY. Okay, it's an acronym, or you can see here RATTEY. All right, here's a graph. It's not a rational function, but we've worked on this as far as graph without a calculator. We talked about our zeros, our multiplicity. Bounces are what are we when we talk about bounces are when we bounce off the x-axis because of an even multiplicity. Here that refers to as a tangency. When you just touch a point just at one point, that's a point of tangency. We're going to call it a bounce or a point of tangency. Okay, so here's RATTEY. R stands for roots. Okay, in the numerator, what are the roots? The zeros, the x-intercepts. Okay, solving, factoring for 0. A is going to be asymptotes or wholes, okay? Remember how we get asymptotes in the denominator, okay? If they don't factor out, remember, asymptotes are when we can find the zeros in the values of x that get you 0 in the denominator, okay? If they don't cancel out, they're asymptotes. If they cancel out, canceled factors are removable discontinuity or wholes. Okay, we're going to look for those. Tangency or bounces. We're going to look for even powers like so, where for zeros, right? This -1 is a 0, and we're going to, at -1, we'll bounce off the x-axis because it's the even power. Even powers bounce, odd powers go through. Togetherness, that's a new phrase, okay? Oh, here, let me draw it down here. Togetherness deals with vertical asymptotic behavior, the behavior by the asymptotes, okay? And it's based on the powers of the asymptote factors, okay? So if you have in your denominator x minus 2 squared, we have a vertical asymptote at where? 2. 2 minus 2 is 0. Okay, so here's your vertical asymptote. What they mean by moving together is as you have points approach from either side, they're going to move together. In this case, they're moving, and this is what an even power would do. Okay, that's an even power. Okay, if you have x minus 2 squared, where you're 0 in the denominator, your asymptote, the 0 that causes the x value, the 0, the value that creates 0 in the denominator, if it's to an even power, the graph moves together. If it's an odd power, it's going to be this. You can have an asymptote and it'll move in opposite directions like so, okay? So in your denominator, the factors that create asymptotes, okay, if they're even powers, the graph moves together, and if they're odd powers, it moves in opposite directions. So that's the togetherness. E is in behavior, okay? So we need to know that. We know the patterns for the degrees of the numerator and the denominator, okay? We know about x to the odd, x to the even. We know if we have a horizontal asymptote, that'll affect things, okay? So in behavior, and the y-intercept, okay? To start a graph, choose an x value on the left and to the left of the leftmost known x. Mark your zeros correctly, graph all asymptotes, colored dashed lines, okay? Here's an example of how we can, this is a little more, this one's a little easier, but it doesn't have a denominator, so I'm going to skip to this one. All right, let's see, we got 3 minutes, I'm doing well. Okay, so here's a graph where they gave us roots of 1, 0, these are my x-intercepts, 1, -2, and 3. Notice the y values are all 0. So, in my numerator, remember we get our roots from the numerator. I will have x minus 1, x minus -2 is x plus 2, and then x minus 3. Because there's my roots. 1, -2, and 3. Okay? Let me just maybe make that a little bigger. Okay? So I'm going to go ahead and mark there's a -2, 1, 2, and 3. So these circles are my zeros, the x-intercepts, okay? I have asymptotes at 0, negative 1, and negative 2. That's going to be in my denominator, right? So x minus 0 is just x, correct, for my root? It's always x minus your root, okay? X minus 0 is just x, so that's x times x minus negative 1, which is x plus 1, and x minus 2. Okay, so I'm starting to get an equation here. Okay? Notice, no holes, so there's no factor now. Notice everything's different. X minus 1, x plus 1, x plus 2, x minus 2, and x minus 3. Nothing cancels out, so there's no holes. Notice, here's this key. I bounce at 1 or negative 2. That's my tangency, okay? So that means what? This one is squared. X minus 1 is squared. And x minus 2 is squared also. So this x plus 2 is squared. But x minus 3, the root at 3 doesn't bounce. So we bounce at 1 and negative 2, but not 3. So this is squared. But what's it tell me? I've got x squared times x squared times x. So this is x to the 5th in the numerator. All right. I have together, this refers to the asymptotes. And if it's together, that means the factor that causes the asymptote is an even power. At x equals 0, that's there. So I'm going to square it. Okay? And at x equals 2, this would be right here. X minus 2, 2 minus 2 is 0. That asymptote, the graph moves together like so. They move together in the same direction. So that would be squared. Okay? All right, so right now, I've got x squared times x squared. These would be x to the 5th. And up top, we had the same thing. We said x squared times x squared times x is x to the 5th. So this is an each DC case, correct? Exponents are the same. Divide the coefficient. Okay? Notice, in behavior is y equals 5. Numerator equals denominator, so y equals, this is your divide the coefficients. Okay? Well, if it's y equals 5, I can put probably like a 5 over here. 10 over 2 or 5 over 1, okay? So the end behavior is I'm going to have some horizontal asymptote here up at 5. So at the very outs of my graphs, at the very outside of these, we're going to have this thing's going to approach 5, okay? All right? There's no y-intercept. Okay, when we get down to the RATTEY, so we got roots, asymptotes, the tangents, which are our bounces, togetherness, in behavior, y-intercepts. Why is there no y-intercept? Because we have an x-asymptote, or I'm sorry, we have a vertical asymptote, no y-intercept, vertical asymptote at x equals 0. All right, so what we do now is let's plot our asymptotes, and we had them at 0, negative 1, and 2. And then I've got up here, this is going to be y equals 5 is an asymptote, okay? All right. What we need to do, and this might take some time, this will be something for class, but we've got on a number line, what you kind of have to do to help you graph totally without a calculator is I've got at negative 2, I've got a value, okay, where this graph could be a positive or negative. I've got an asymptote I need to know about where my behavior, where my graph's going to be, and that's at negative 1. I've got an asymptote at 0. I've got these are all what I consider critical values. I've got another 0, a root at 1, asymptote at 2, and another 0 at 3. So all these, this could take some time for this function, but basically, you can use test cases like what's to the left of negative 2 would be negative 3. And I can plug that in to this graph. And basically, you don't really have to get values so much as positive or negative, okay? Like this could be what? Negative, anything squared is going to be positive. So that'd be, and this is positive, so I forget my numbers are positive. So positive, this is going to be squared, it's going to be positive, and negative 3 minus 3 is a negative. So positive times a negative is a negative, okay? and then I put negative 3 in the denominator. Squared is positive, okay, times a negative 3 plus, plus 1, that's a plus 1, okay, and that is, that was a, that's a plus 1. So I plug in negative 3 here is squared, negative 3 here, negative 3 plus 1, that's still negative, and negative 3 here is squared. That's anything negative is, anything squared is positive. So in both cases, I have positive times negative equals a negative. Positive times negative is negative times a positive is a negative. But negative over negative is a positive. So that would be a positive value. Okay. So from negative 2 on, my graph is positive. Okay. All right. So, and then we can do that for negative, a test value here like negative 1.5, negative 0.5, and this is pretty detailed. This is one of the worst type graphs, okay? But here you can see how I came up with an equation, okay? And here I'll graph it for you. And we actually, in this one, this section here was way down. But here's the graph, if you can see it. Now my scale goes down to about 150, and this is 20. Okay, but my normal scale for x goes from negative 10 to 10. But here's my asymptotes at negative 1, 0, 2. I've got y-intercepts like we had. Where were my y-intercepts? I have y-intercepts here at negative 2. Where else were they? Negative 2, 0. Negative 2 at 1. And at 3. So 3, 1, and negative 2. Sorry, guys. Negative 2, 1, and 3 were my x-intercepts. You can see the asymptotes. The end behavior, see how this approaches 5 here, and this approaches 5. That's your end behaviors. You get very negative and very positive. Approach negative infinity, approach positive infinity. This approaches the asymptote, y equals 5. Okay? All right, and that was given to us. Okay? So that's kind of an example of how we can do our graphs now. It's 12 minutes, so remember, RATTEY is summing up our roots, zeros, intercepts, a's, asymptotes, or holes, tangency, that dealt with our numerator. If it's even, we bounce off, like up here at negative 1. Togetherness, we talked about odd powers in the denominator for the asymptotes. They go in opposite direction. If it's even powers, the graph moves together. Odd, it goes apart. Okay? E is in behavior, and y is the y-intercept. Okay? All right. That's it. I'll see you tomorrow, and we can do some graphing.